आज का मेरा टॉपिक कोवलेंट बॉन्ड के हवाले से है। आयनिक बॉन्ड। आइडियली द इलेक्ट्रॉन क्लाउड्स ऑफ ईच आयन डू नॉट ओवरलैप. Electron transfer occurs from metal to non-metal and resulting ions attract only by electrostatic attraction. Ionic compounds. Ionic compounds have a rigid and strong crystal lattice structure in which the ions are arranged in an orderly repeating pattern. Covalent bond. Electrons are shared between two or more non-metal atoms in a molecule. There are no ions. Electron clouds of adjacent atoms overlap and merge to form new bonding orbitals, a process called hybridization. Most covalent substances have a molecular form. There are covalent bonds inside molecules but not between them. The attraction between molecules are called intermolecular forces as opposed to intramolecular forces, which are true covalent compounds. The strengths of the intermolecular forces determine the melting and boiling points of molecular substances. You do not break any chemical bonds to melt molecular substances. Electronegativity. Electronegativity, a measure of the ability of an atom to attract shared electrons in a chemical bond on a relative scale of 0 to 4. American chemical Linus Pauling developed this concept. The noble gases are not ranked because they do not form bonds. Notice that fluorine is the best at attracting electrons in a bond. Finding the difference in electronegativity between two bonded atoms can be used to predict whether a specific bond is more ionic or more covalent. In reality, most bonds are little of both. Change difference in electronegativity is calculated for each bond in a molecule. Just subtract the electronegativity values of the two bonded atoms. Difference of electronegativity is greater than 2.1, then bond is ionic bond. Electron transfer from between two atoms. Difference in electronegativity is equal to 0.4 to 2.1. Polar covalent bond, unequal sharing of the shared electrons between two atoms. Difference in electronegativity is less than 0.4. Pure covalent bond, non-polar covalent, essentially equal sharing of the shared electrons between two atoms. Examples: predict the bond type based on difference in electronegativity. Difference in electronegativity values are always positive. The first one is done for you, Na, sodium and chlorine. The electronegativity of sodium is 0.9 and of nitrogen is 3. The difference in electronegativity is 2.1. Then bond is polar covalent bond. Polar covalent versus pure covalent bonds. The oxygen-hydrogen bond, the difference in the electronegativity is 1.4 in water, is a polar covalent bond. The shared electrons spend more time with oxygen than with hydrogen. Thus, the electron sharing is uneven. The bromine iodide bond difference in electronegativity is 0.3 in bromine iodide is a pure covalent non-polar bond. The shared electrons essentially spend equal time with bromine and iodine. Covalent bonds are like springs. The atoms can vibrate back and forth to some extent without the bond breaking. The strength of a bond is related to its length, which is in turn related to the radii of the bonding atoms. Bond length. Bond length is the average distance between the nuclei of two bonded atoms. It is the position of highest stability that balances the forces of the attraction and repulsion between two bonded nuclei. Energy is released when bonds form from atoms. The chemical potential energy of the chemical system is minimized at the ideal bond length distance. Comparing bond length versus bond energy. Bond dissociation energy is the amount of energy needed to break a bond. It is the same amount of energy as was released when the bond formed. As bond length increases, bond energy decreases. In other words, longer bonds are weaker and easier to break than shorter bonds. PM is picometer or 10 to the power is to negative 12 meter. Bond hydrogen bond. The bond length of the hydrogen bond is 75 picometer and bond energy is 436. Hydrogen carbon bond length is 109 and bond energy is 418. The bond length of hydrogen chlorine is 127 pm and bond energy is 432. Hydrogen bromine bond length is 142 pm and bond energy is 366. Hydrogen iodide length is 161 and bond energy 298. Unstable molecule nitrogen iodide 2Ni3 gives us N2 plus 3I2. Iodine is a much bigger atom than nitrogen. The nitrogen iodine bond is long and weak. Tickling from a feather is enough to break the bond, producing diatomic nitrogen gas and solid diatomic iodine, the purple smoke. So Ni3 is very unstable, but N2 is very stable triple bond. To calculate the energy needed to break all bonds in a molecule, first draw the Lewis structure of the molecule in order to see what specific bonds are in the molecule. Number 2, second, use a table of average bond energies to look up each type of bond. Pay specific attention to whether the bonds are single, double or triple. Third, add together the bond energies of each bond in the molecule. Example, calculate the energy needed to break the bonds in hydrocyanuric acid. Lewis structure HCN. Total energy to break bonds in HCN is HC bond is 413 kilojoule per mole. CN bond energy is 891 kilojoule per mole. Single versus double versus triple bonds. Bond length versus bond energy. Carbon-carbon single bond length is 154 and bond energy is 348 kilojoule per mole. Carbon-carbon double bond length is 134 picometer and bond energy is 614 kilojoule per mole. Carbon-carbon triple bond length is 120, bond energy is 839. Nitrogen single bond length is 145 and bond energy is 170. Nitrogen double bond length is 124 and bond energy is 418. Nitrogen triple bond length is 110 and bond energy is 945 kilojoule per mole. When you compare bonds made between the same two atoms, triple bond are generally stronger and shorter than double bonds, which are generally stronger and shorter than single